So hello everyone. In this video we're going to learn how to calculate implied volatilities in Excel. And the way we're going to do this is we're just going to solve question 1 in homework 14 that concerns implied volatility. So what this question is going to do is it's going to give you some option inputs, so parameters that go into calculating a Black-Scholes option price. It's then going to tell you what the actual market price is in the real world. And then what we're going to want to do is we're going to want to back out the volatility that's implied by this real world market price. Okay, so let's read the question. Today's price of Amazon is $1,500 per share. Amazon, like usual, does not pay dividends. You're interested in a European call option on Amazon with a strike of 1,450, so it's in the money, and a maturity of 6 months. The market price of this call option is given to you. The trader, say, quotes it at 172.93. Continuously compounded risk-free rate is 10%. There's no arbitrage, and what we want to do is we want to calculate the implied volatility of this call option on Amazon, or in other words, what is the volatility sigma that, given these inputs, sets the price of the option in the Black-Scholes model equal to the market price of 172.93. So the way you go about doing this is you just open Excel. Okay? And I'm going to do this in a slightly different way than what I described in the slides, so you have two different approaches that you can go about it. The way I like to do it is start by writing down the inputs. Okay? So the stock price, spot stock price of Amazon today is $1,500. The continuously compounded risk-free rate is 0.10, 10%. And we're interested in a European call option on Amazon, okay, with a time to maturity of half a year and a strike of 1,450. What we want to do is we want to calculate the implied volatility of this option once we know what the market price is. So we're going to leave blank here an input for sigma that would go into the Black-Scholes model. The outputs are as follows. I'm going to save some space for D1 and D2. We know that the call options price in the market is 172.93. We're going to want to calculate what the call options Black-Scholes price is. Okay? And what we're going to want to do is we're going to want to choose this value of sigma over here such that the call option price C0 Black-Scholes, once we calculate this out, is going to equal the market price that's quoted to us. Or the difference, okay, between these two, we want equal to 0 in terms of square root here. So let's go about doing this. Okay, what we're going to want to do to start off is just pick some arbitrary value for sigma. Just do any value, you can put it in. Let's just say we put in 5%. Okay, this is not going to matter. We're going to solve for this sigma to match up whatever we calculate as the Black-Scholes price with the market price. What we now want to do is we want to calculate the Black-Scholes price given these option inputs, and it's a call. We start by writing down some formulas for D1. D1 is equal to the natural log of S0 over K plus the risk-free rate plus 0.5 times sigma, which is just arbitrarily chosen here, squared times the time to maturity, T. Okay, all over sigma times the square root of T. D2 now is just equal to D1 minus sigma times the square root of T. And the Black-Scholes call option price from the slides in lecture 14 is just the spot price, S0, times norm.s.dist by D1, norm.s.dist D1, true, minus the present value of the strike, K times exponent negative times T times phi D2. So norm dot S dot dist and D2 true. Okay. So given a spot price of 1500, a risk-free rate of 10%, a maturity T of half a year, a strike on a call option of 1450, and an arbitrarily chosen volatility of 5% per annum, the Black-Scholes call option price would be 120.86. However, what we know is that the Black-Scholes call option price in the market is 172. And so what we want to do is we want to choose the value of sigma that's going to set these two equal, or set this difference equal to 0. So we want this to be 0. Okay. The way you could do this, you could solve this by just guessing and checking. So what you should see is that as you increase the sigma, the call option price will increase in the Black-Scholes model. So say here we choose 10%, the call option price in the Black-Scholes model is 126. If we choose 20%, it increases up to 155. And if we choose, say, 50%, it goes all the way up to 267. Okay? So you could guess and check around and find which sigma is going to equate these two prices, the market and the Black-Scholes price. Okay? But an easier way is to just go about and have the computer do it for you. Okay? There's two different ways to do this. I'll show you them both. They both use this thing called goal-seek. So you're going to go up to the Data tab in Excel, and you're going to click on this button over here called the What If Analysis. Click down to this thing called goal-seek, which is going to be a numerical solver for Excel. And what you're going to do is you're going to tell goal-seek a given cell that's a formula or an input of a bunch of different things. You want to set the cell to a certain value, and you want to give it a single input to change. So it's an optimization problem, okay, changing a single input. What we want to do is we want to get the Black-Scholes call option price over here. We want it to equal the market price. Now you're not going to be able to click an actual value here. You're going to have to hard code it, 172.93. Okay? So we want to set the Black-Scholes call option price equal to the market price. This is how you back out implied volatility. And the way you're going to do this is you're going to change the volatility cell. So you want goal-seek to go about and guess and check over all the possible volatility values until it finds one, okay, that's going to set the Black-Scholes call option price equal to this market price. And watch this, it's going to solve it right for you if you click OK. Okay, so what does that say? Look at these two, exactly the same, right? And what the sigma is going to be is it's going to be 25%. So the implied volatility is 25%. Okay, that's one way to do that. That's actually not the way I did in the slides or recommend it. The way I do it in the slides is say you have this arbitrarily chosen value of sigma. What I do in the slides, or what I tell you guys to do, is to use goal-seek again, top right-hand corner, what if analysis, okay, under the Data tab in Excel. I tell you to use goal-seek to set this square difference term right here, which captures the square difference between the Black-Scholes and the market price, equal to 0 by changing this input sigma over here. Okay? What you're going to see is you're going to get the same exact thing. Okay? This is going to be, you know, a little off in numerical terms, but when you do the rounding, like in the test, you're going to get that it should be 25%, and it will be within the margin here. Okay? So that's how you do implied volatility calculations in Excel. What you do is you write down the inputs. Okay? Given those inputs, the main thing you want to solve for is sigma. You take it as just given at the beginning. You just pick some arbitrarily chosen value. Given these inputs, you then figure out what the Black-Scholes price is. The formula for the Black-Scholes price will change depending on whether it's a call or a put. Okay? And then what you do is you use goal-seek to set the Black-Scholes price equal to the market price. So the way you do it is you go to Data, goal-seek, you set the cell, the Black-Scholes price, equal to the market price, 172.93. By changing the input sigma, you get 25%. Alright guys, so that's the end of this short video. Hope it was informative, and I'll see you in the next video.